For decades, Mars has fascinated scientists as more than just a distant red planet. It is a world that once had rivers, lakes, and conditions that may have resembled early Earth. But one question has quietly guided much of humanity's exploration of Mars. Could the basic ingredients for life have ever existed there? In 2012, NASA's Curiosity rover touched down inside Gale Crater, a vast impact basin believed to have once hosted liquid water. Its mission was not to search for life directly, but to understand whether Mars ever had environments capable of supporting it. What Curiosity would eventually uncover would reshape how scientists view the planet's past. Years into its mission, Curiosity began drilling into ancient sedimentary rocks, some dating back more than 3 billion years. These rocks formed during a time when Mars was warmer and wetter, long before it became the cold, dry world we see today. Inside these samples, scientists detected something remarkable: organic molecules preserved in the Martian soil. Organic molecules are compounds that contain carbon, often bonded with hydrogen, oxygen, nitrogen, or sulfur. On Earth, they are fundamental building blocks of life. However, scientists are careful to clarify that organic molecules do not automatically mean life. They can form through non-biological processes as well, such as chemical reactions driven by heat, radiation, or water. What made this discovery important was not just the presence of organic molecules, but their age and complexity. The compounds were found in rocks that formed billions of years ago, suggesting they had survived intense radiation, oxidation, and extreme environmental change over immense spans of time. This challenged long-held assumptions that organic material could not persist on the Martian surface. In 2018, NASA scientists published findings showing that Curiosity had identified organic compounds such as thiophenies, aromatic hydrocarbons, and aliphatic chains. These molecules were detected using the rover's sample analysis at Mars instrument, which heats rock samples and analyzes the gases released. The results were carefully reviewed and confirmed through multiple tests. At the same time, Curiosity measured seasonal variations in methane levels in Mars' atmosphere. Methane is another molecule of interest because, on Earth, it is often produced by biological activity. However, it can also be generated through geological processes, such as reactions between rock and water. Scientists emphasize that the source of Martian methane remains unknown. Together, these findings painted a clearer picture of ancient Mars. The planet once had liquid water, energy sources, and organic chemistry occurring at the same time. In astrobiology, this combination is considered essential for habitability. It does not prove life existed, but it confirms that Mars once met many of the conditions required for it. Further analysis revealed that the organic molecules were likely preserved in clay-rich rocks. Clay minerals are known on Earth to protect organic material by shielding it from radiation and chemical breakdown. This discovery suggested that Mars may still contain well-preserved records of its early chemical history beneath its surface. NASA scientists were careful in their language. They did not claim evidence of past life. Instead, they stated that these findings demonstrate Mars was chemically active in ways that mirror early Earth. This distinction is critical, both scientifically and ethically, as extraordinary claims require extraordinary evidence. In the years that followed, additional studies reinforced these conclusions. Improved laboratory techniques on Earth allowed scientists to better interpret Curiosity's data, ruling out contamination from Earth and confirming that the molecules were indeed Martian in origin. Meanwhile, Mars exploration continued to build on this foundation. In 2021, NASA's Perseverance rover landed in Jezero Crater, a region believed to have once hosted a river delta. Its mission includes collecting rock samples that will eventually be returned to Earth for direct analysis. These samples may contain even more detailed chemical signatures than Curiosity could detect on Mars itself. The discovery of organic molecules on Mars represents a shift in planetary science. For much of the 20th century, Mars was thought to be largely sterile and chemically inactive. Today, it is understood as a planet with a complex history, shaped by water, chemistry, and time. Scientists emphasize that Mars is not unique in this respect. Organic molecules have been found on comets, asteroids, and even in interstellar space. This suggests that the basic ingredients of life are widespread throughout the universe. Mars, however, offers a rare opportunity to study these processes on a planet that once closely resembled Earth. The presence of organic molecules also raises important questions about planetary preservation. If such compounds can survive for billions of years on Mars, they may also be preserved on other worlds with similar conditions. This has implications for future missions to icy moons like Europa and Enceladus. Today, NASA continues to analyze Martian data with caution and precision. Each discovery is treated as one piece of a much larger puzzle. Rather than searching for dramatic conclusions, scientists focus on building a consistent, evidence-based understanding of Mars's past. What Curiosity revealed is not a story of answers, but of possibilities. Mars was once a planet where chemistry and environment aligned in ways that are scientifically meaningful. Whether life ever emerged there remains unknown, but the conditions that make life possible were undeniably present. As future missions prepare to bring Martian samples back to Earth, scientists believe the most important discoveries may still lie ahead. Until then, the organic molecules detected by Curiosity stand as one of the strongest indicators that Mars was once a far more dynamic and intriguing world than we ever imagined. In studying Mars, humanity is not only learning about another planet, but also gaining insight into its own origins. The story of organic molecules on Mars is ultimately a story about how common the building blocks of life may be in the universe, and how carefully science must proceed when exploring questions that touch the very edge of what we know.
Touchdown confirmed. Perseverance is safely on the surface of Mars.
Sample secured. We are moving toward the designated habitat now. Air checks remain nominal.
Asteroids and comets journey through the void, carrying the building blocks of life across the cosmos.
Earth, a vibrant oasis of water and air.
Touchdown confirmed. Perseverance is safely on the surface of Mars.